Today we will discuss about fields. So before that, I want to tell you something. So this is the starting of 12th class, and if you have remembered, you have studied about the mass in the 11th class. Is it right or not?
I am in 11th now. We just started classes.
You have completed your 11th now?
No, I am in 11th right now.
You are in 11th, but I am here to teach you the topic of 12th class, like electric charges and field.
But I'm in 11th grade. I did tell them I was in 11th grade.
This topic is okay now? You want to study
Yeah,
this topic? Okay, that's fine. That's
yeah,
fine.
that's all right.
That's fine. So actually, basically, what we are studying, electromagnetism, and this electromagnetism, and see, this is the starting of 12th class. Okay, so in the beginning, I will tell you about the introduction, and after that, we will discuss about further. So electrostatics, electromagnetism can be divided in electrostatics and electrodynamics. Are you okay with my writing or my voice?
Yes, it's
Okay,
absolutely okay.
okay, that's fine. So basically, we have to study this electric charges and field. And before that, I am giving you a brief idea of what is this. Now we are dealing with the electromagnetism. And in electromagnetism, we have electrostatic. This electromagnetism is further divided into two parts. We have electrostatics and electrodynamics. In electrostatics, we study about the charges at rest. And in this, we will study about charges in motion. And now we will start. This is just an information for the introduction. So now, you know about the mass. You know about the mass. Do you know about the mass, na?
Yes.
Okay. You have heard about the mass. And now there is new thing to use, charge. The whole story begins with charge. Charge. So now, what is charge? So basically, intrinsic property of matter. So about the charge, we can say charge is an intrinsic property of matter, intrinsic property of matter, and we know about the matter, and we know about the what is intrinsic property. If we can say like internal properties, and we know about the matter. Anything which occupies space and has mass is known as matter, and which give rise to the phenomenon like electric field and like electric force and electric field and energy. And this we will discuss in the further discussion, these things. So this is the definition of charge. And maybe you know or not, charge is of two types: positive charge and negative charge. And please have patience, because this is the starting of this chapter. And this charge now is given by someone, we can say Greeks, like discovered by Greeks in 600 BC. This is not an important thing, but just for the interest, I am telling you. And charges are of two types. One is positive charge and another is negative charge. And there are some properties of these charges. So I can say, if I am putting here a positive charge and at some distance I am putting a positive charge, so will it repel or attract? Can you guess?
It repels.
Very good. This thing we know. We knew this thing. And now I am putting one positive and another negative. And this is the distance between them. Suppose this is D1 and D2. D1 and D2 represent the distance between. What will happen? Attraction. Attraction. And negative and negative. This is very basic thing. Or again repel. So this thing we know, if we put two positive charges, these will repel and attract and repel. So charge is a scalar quantity. Charge is a scalar quantity, means for the charge we calculate only magnitude, not direction. And there are two types of quantities. One is scalar quantity and another is vector quantity. So charge is basically a scalar quantity. So is it clear?
Yes, sir.
This is the basics. And SI unit of charge is Coulomb. And we represent Coulomb with C. Coulomb with C. This is the thing. Now, if we see this portion, like this positive charge and positive charge when placed at a distance, they repel each other, and one positive and one negative attract each other, one negative and one negative repel each other. But we know this, but we don't know how much, by how much amount they will repel or attract each other. Okay, by much, by how much amount they will attract or repel each other. And for that, there comes a scientist known as Coulomb, and he has given the Coulomb's law. Now we will discuss Coulomb's law. So basically, this law is to calculate the magnitude of the force and direction of the force. Suppose these are two positions, and at this position a charge Q1 is placed, and at this position a charge Q2 is placed, and this is the distance between two charges. As in the earlier case, you can see here, there is a charge and there is another charge and separated by some distance. So like this, here is a charge, here is another charge and separated by some distance. So we also know that there will be the interaction between the charges, means they can repel or attract. They can repel or attract, means they try to force each other either by repelling or attract, either by repulsion or attraction. So it means that when you place two charges with some distance, then there will be a force of attraction or repulsion, means there will be a force. This funda is simple. There is the existence of force, and this force is found to be directly proportional to the product of two charges which are separated by some distance r. This is point number one. And there is another thing also. The force of interaction between the two charges is also inversely proportional to the distance between them. And also this force depends upon the medium between the charges. So now from here I can write F is directly proportional to Q1 and Q2 and inversely proportional to R square. And when I remove this proportionality sign with equal sign, we got a constant. This is not R2, this is R square, okay? And this is the force of interaction between any two charges which are separated by some distance. And this K is constant. This K is constant, and the value of this K is 1 upon 4 pi epsilon naught. Not epsilon naught, sorry, epsilon. The value of K. And this epsilon is the absolute permittivity of medium. So see here, these are two charges and separated by some distance, but between these two charges there can be any medium, there can be air, there can be any other medium other than air. Okay, fine.
Yes,
Is it
sir.
fine? Is it fine? Okay, good. So force is directly proportional to product of two charges, and force is inversely proportional to square of distance between two charges, and also this force depends upon the medium between the charges. If we replace the medium with another medium, then there will be change in this force, and you will see that. Suppose these charges are placed in air. So for air, we use epsilon naught. These are the experimental things. Okay, and if I want to write, like if two charges, like here is one charge q1 and q2, and these two charges are separated by some distance, r is some distance. So the value of force is equal to k q1 q2 by r square, and here we will put the value of k as 1 upon 4 pi epsilon naught q1 q2 divided by r square. So for air we will use this formula. Okay, if two charges is placed in air, if two charges is placed in some medium, here I have not defined whether these charges are placed in air or something. So here I am saying uh, simply epsilon naught. Here I have taken epsilon naught. This is absolute permittivity of medium. Okay, so you should remember this formula. Whenever there are two charges, may be positive, may be negative, there will be the force of interaction, as you have told me that either they will repel or they will attract, and how much they will repel or attract will given by this formula. And one thing more, one thing more. This Coulomb's law, we are using here, these are the point charges. Huh? Point charge. So now, do you know about the point? What is point charge?
Actually, no, I don't.
Okay, okay, no problem. So there is no fixed definition of point charge, but please try to feel this thing. Point charge means like, what is point? Point is this. Sorry, this is our point. So point charge is, we can say, the charge in very small space. The charge in very small space. This is a point charge. But suppose if I am taking a charge. Now, are you familiar with charge? Huh?
Yes, sir.
Charge is something like mass, intrinsic property of matter, which give rise to the phenomena like electric force, electric field, and energy. And I have not uh, going into the detail of charges, as we will move forward, and you will understand the concept what are charges. So you should remember these things, that charges are of two types, like positive charge and negative charge, and this thing we know. And after this thing, we calculate how much amount, by how much amount will be the repulsion or attraction, by with the help of Coulomb's law. This is experimental law. Okay. So, and now this, and after that this, and here is a k. The value of k is like this. And if we are placing a charge in air, here you are placing a charge in some medium. Do you know what is medium? Medium means like air is a medium, like
Yes, sir.
steel can be a medium. Medium means, suppose this is one charge and this is another charge, and in between these charges, whatever exists is known as medium, simply, whether it is air or vacuum, no matter. So this thing is now also valid for vacuum. So vacuum is something you can say, like, see here, these are my hands, and in between my hands, what is in between my hands? Not my
Air.
face, not my face. Like you can see now here. Now, what is in between my hands?
Yes,
Air,
sir. Air. Yes,
air.
sir.
So if somehow you remove this air by the vacuum cleaner, the vacuum cleaner. So
Yes,
that
sir.
produces the vacuum. Means what will that device do? That device will remove the air from this portion, and here is completely vacuum. That is known as vacuum. Means there is nothing, no particle. In air we have particles, like here is the air, so there can be the particle of air now, but in vacuum there are no particles. But approximately we assume air and vacuum, this formula is same for air and vacuum. Approximately it is found to be equal. So if there is air or vacuum, so you should apply this formula 1 upon 4 pi epsilon naught q1 q2 by r square if you want to calculate the force. So I was discussing about the point charge. So this is the point charge, means charge in very small space. So this is a charge in very small space. This is, what is this space? This is very small space. No problem. This is a point. And suppose this is 1 meter. So 1 meter is like, you can say like this much amount of charge. You can imagine now 1 meter charge of spherical charge.
Yes.
Okay, fine. And now, suppose there is another charge of radius 2 meter, and the distance between them is 10,000 mean 1 lakh kilometer. This is just an example. So when this is the distance between the charges, it is very large distance as compared to the radius of these charges. These are charge 1 and this is charge 2. So you can consider now these charges also as point charges. Why? Because the distance between the two charges is very large as compared to the size of the charge. So here you can all consider these charges as point charges. Are you getting my point or not?
Yes, sir.
So is it fine now? What are point charges?
Yes, sir. Understood.
And now you always apply this formula only on the point charges. And there is something else I want to discuss. So you can say for a point charge like charge in very small space. And also you can say depends on distance. But please remember, this is the most important formula. These are the things for just understanding, and this formula we will use in the numerical that we will do. Okay. Now, I have told you that force equal to K Q1 Q2 divided by R square. Suppose this is for air or vacuum. Air or vacuum. Two charges are placed in air or vacuum. So we will apply this formula. Now we will use the value of K as 1 upon 4 pi epsilon naught. And the value of this epsilon naught is 8.85 into 10 to the power minus 12. 8.85 into 10 to the power minus 12 Coulomb square meter minus 2 and Newton minus 1. You should simply remember this value. And if I put this value here, we know the value of pi. What is the value of pi?
22/7 or 3.14.
Okay, fine. Fine. So now, can I put this value here?
Yes, sir.
And we will got the answer. We will got the answer 9 into 10 to the power 9 Newton meter square per Coulomb square, or you can also write the unit Newton meter square or Coulomb minus 2. Can I write now?
Yes, sir.
So please learn this value of K for air will be 9 into 10 to the power 9. This is 9. This is the value of K. this thing. And what is the value of K for air? This thing. And this thing. And this formula is also very important. And for a medium, you can use this. So all the things are same, but they are different. These are the different form of this formula. Okay, formula is same. Formula is like K Q1 Q2 by R square, but the value of K in medium is something else. In another medium is something else. Now, unit of charge is Coulomb. This is 4 Coulomb, and this is a positive. There are two types of charges: positive charge and negative charge, separated by 1 meter. This question is just for your understanding. Suppose this is position A and this is position B. And now, first tell me, what is the force of, will these charge repel or attract?
They're opposite charges, so they'll attract.
Very good. Opposite charges attract means this charge will try to attract this charge like this, and this charge will try to attract this charge like this. Okay, this charge is all. So this is now, this is okay now. Hello. Okay, fine. So okay, fine. So what I am saying, I want to know the value of force if these two charges are placed in air. So what will we do? If we want to calculate this attraction, how much this attraction is, what is attraction? Attraction is a force. Repulsion is a force. So we want to calculate this force, and this is placed in air. So K Q1 Q2 divided by R square. And how much the value of K for air? This is the value now.
Yes.
So 9 into 10 to the power 9 and 2. This is 2. And this is 4. And this is 1 ka square. And now, can you please tell me the answer?
So 72 and
okay, no
yes.
problem. And what is the unit of force?
Newton into meter.
No.
Yes.
No. The unit of force is simply Newton, and we represent Newton by N.
Okay.
Newton is the name of scientist also, and it is also the unit of force. Fine. And from here, we can also add 1 point. We can also 1 point more here. See here, not here. Please try to understand. Suppose there is one charge here. There is a I can say Q1 charge, and there is another Q2 charge. This is the line joining between the two charges. Okay, this is the line joining between the two charges, and here if I want to find the direction of force, because force is a vector quantity now. So here why I have not you have not asked me why, sir, you have not take this charge with minus sign here, because I have calculated the magnitude. This is magnitude. I have already told you force is vector, and for defining the vector, we require magnitude and direction, and you know the direction like east, west, north, south, and magnitude means like how much amount, in how much amount. So here we have calculated the force in how much amount. This is the magnitude. And direction we know. We know the direction now. Here means we have calculated all the things. So there are two charges, and suppose this is positive charge and this is again a positive charge. So can you please tell me at this charge, first tell me this charge will repel this charge now?
Yes, sir.
Why? Because positive charge repel each other. So repel this charge means this charge will try to push this charge like this. So if you want to find the direction of the force, so here is positive, means this sign will be away from this. Okay, will be away from this, like arrow will be in opposite direction. So what is the direction of arrow? Like this here.
No, sir, it'll go reverse, right?
Good. Okay, good. Because this arrow represents the direction of force. Here is force due to charge 1 on charge 2, or you can write this in another way also, so you will not get confused. So you can simply write this is F1 and this is F2. F1 is force on this charge, Q2 due to Q1, and F2 is force due to charge Q2 on Q1. So this is the direction. And one thing more, these forces will exist along the line joining between two charges. Okay, so I can say force, this is force, acts along the line joining the two charges. Okay, is it fine now? Hello. Hello.
Sorry, sir.
Okay,
Sorry,
no
sir.
problem. No problem. Have you understood this point? Actually, I am telling that here are two positive charges, and the this is the direction of force due to charge 1,
Yes, sir.
and this is the direction of force due to charge 2.
Yes, sir.
Okay, and this force act along the line joining the two charges, means it will be acted like this. And please tell me one thing more. Like if there is charge, if here is a minus q charge and here is q2 charge, so at this point what will be the direction of arrow? Like this?
No, sir. We'll move towards Q1
Very good, very good. Why?
because Q1 is negative and Q2 is positive, so they are opposite charges and they will attract.
Fine. So here also direction of force, we got the direction. How to calculate the direction? And direction will be along the line joining, and if I want to calculate the magnitude, then we have the formula k q1 q2 by r square. So simple. And we know the
Yes.
value of k and all that. Now there are some characteristics. Okay, fine. Characteristics of Coulomb's law. Okay, so this law is only valid for point charges, as I have discussed this point earlier. Okay, fine. What is point charges? You know very well. I have given an example also. Am I audible?
Yes, sir.
So this law is only this law. What is the validation of this law? Why we are saying this law is valid? Valid means We cannot calculate the value of force when there will be charges other than point charges. This is the okay. This is the meaning of this statement. This law is valid for only point charges. There can be other charges also, na, from the point charges.
Yes,
But
sir.
but this law can only calculate the value of force due to the point charges. But if someone gives us charges other than point charges, then we will discuss that in the later of this chapter. So, and also we can say here I have told you that here these charges are moving or at rest.
They're at rest.
They are at rest now. So
Yes, sir.
see this statement. This law is valid when two charges are at rest. Okay, this law is valid now when two charges are at rest.
Yes, sir.
But there is another condition also. One of the charge it at rest and distance between them is constant. Leave this statement. And now I am saying there is charge Q1 and there is charge Q2. And initially, okay, no problem. No need to write the distance. No need to write the distance. And suppose this is moving like this with some velocity v1, and this also is moving like this v2. Can we apply here the Coulomb's law or not?
No, sir.
No, no, no. Okay, you should remember this point also. If two charges are moving, if two charges are moving, we cannot apply the Coulomb's law. We can only apply Coulomb's law either the two charges should be at rest or one charge is at rest, but the distance between that charge should be constant. When we will solve the numericals, there will be more clarity. And I am giving one example of this. I am giving one example of this. This one. This one, we have the example of this one. Both charges are rest, but suppose there is one charge, like this is one charge Q1, and there is I am trying to make a circle. Okay. And there can be another charge here. This is Q2, and this charge is moving in this circle. So means this charge it is at rest. Okay, this charge it at rest and this charge is moving. And will this distance will change? This R will change during the whole journey of Q2?
No, sir.
No, na? Very good. So similar case you can consider for. So here we can apply this law. And I am giving an example also. We know atom. We have
Yes.
heard, we are familiar with atom, and we are also familiar with nucleus. We are also familiar with electron. Okay, that is fine. what happens in atom? Here is nucleus, na? Positively charged nucleus
Yes, sir.
in atom. This is atom. And what is here? Here electron. Electron revolves the nucleus, na? This is nucleus. Positively charged nucleus at rest, and this electron revolves the nucleus. Here also we can apply the Coulomb's law. Okay.
Yes, sir.
Can nucleus move?
No, sir. It's in the center of the atom.
Okay, fine. That is fine. So hope you have understood the concepts of Coulomb law. And if you have any doubt anywhere, you can ask me. I have
No, sir. No
tried.
doubts.
And so I want to ask you one question. Suppose this is a charge. You should be familiar with this term, charge. And like mass, na, you are familiar with mass. So now you should be familiar with charge because we are dealing with charge. So suppose this is a charge, spherical charge, and this charge have a radius of 3 meter. This is charge Q1, and this is another charge having a radius of 4 meter. And these both charges are separated by 1 meter. So can I say these charges as point charges? Or can I apply here the Coulomb's law? Please tell me.
No, sir. They're not point charges, so you can't apply the
Very
Coulomb
good.
law.
Very good. That's fine. So now I think you should note down the information, this information, all the information. Okay. And now what we are studying, the unit name it is electrostatics. Okay. Should know this.
Yes, sir.
Electro means charge, statics means at rest. No problem. That is fine. So, or this is our first chapter. This is our first chapter. This is a part of electrostatic. Okay. In electrostatic, we have several chapters. And electromagnetism is something like in electromagnetism, there is electrostatics and other things. So you should write from here. You should write first this, now. First, you should write electromagnetism and this, and after that, write this, and after that, from here, you can write all these. Okay. And please ask me to scroll down when completed. And if you have any doubt, you can ask me.
Okay, sir.
Please note down. Are you from CBSE board?
Yes, I'm from CBS.
And you are in 11th right now.
Yes, sir. I'm the batch that just finished 10th.
Okay, fine, no problem. So you can note it down. And
Yes.
if you have not understand anything about the writing or about the uh, speaking, and you can ask me. Okay. Suppose if you are not understanding my writing, what is this? What is this? I have written like intrinsic I. So you can ask me.
Yes. Yes, sir. Done, sir.
Done now? Should I scroll down?
Yes, sir.
Give me a minute.
Yes, sir. Done.
Okay. And one thing more, this force is the electric force because this is due to electric charge. So this force is electric force. So you can write also electric force.
Yes, sir. Done.
Okay. This completed Coulomb's law.
Yes, sir. Yes, sir. Coulomb force is completed.
Till here you have completed, na?
Yes, sir.
And this one, this.
Yes, sir. Yes.
And this.
Yes, sir. Noting it down.
Actually, you are writing with me.
I did note a little bit of it already.
Okay, no problem. So means you have completed till here also. This one also completed. Point charge.
Yes, sir. Point charge, I noted it. I was just writing
Okay.
that this, yes, sir, the equation.
You are writing this, na?
Yes, sir, the numerical, yes.
Okay. Please write. And please tell me from where you want to note. Completed till here.
Yes.
Please write. Completed?
Yes, sir.
Okay. If anything left, please tell me. Okay, no problem. So, should I move forward?
Yes, sir. I'm done.
Now, this is 1, this is milli, and this is coulomb. 1 millicoulomb means 10 to the power minus 3 coulomb. And 1 micro, this is mu, na? 1 microcoulomb means 10 to the power minus 6. And these things, you should remember these conversion, and as we will use this conversion into in the questions. Okay, so there is one question: two charges of plus 2 millicoulomb and minus 3 microcoulomb are placed in air at separation of 3 mm, and 1 mm is equal to 10 to the power minus 3 meter. Calculate force between them. This is the question. So we have two charges. One charge is of plus 2 millicoulomb and another is minus 3 microcoulomb, and this distance is 3 mm. And we have to find the force between them. What we will use here, we can find the force with Coulomb's law. So direction of force will be like this, as the force is of attraction. So we have the formula. You should remember this formula always: K Q1 Q2 for air divided by R square. And the put the value of K. K is 10 to the 9 into 10 to the power 9, and now value of Q1. What is the value of Q1? 2 millicoulomb. So 2 millicoulomb is converted into coulomb, means 10 to the power minus 3. And after that, I am supposing this as a Q1. You can also suppose this as Q1, no problem. That's not a problem. So
Yes.
3 into 10 to the power minus 6, and this will be 3 into 10 to the power minus 3 and the square. And please tell me the answer. So,
So is it 18 to the power 10 18 times 10 to the power 6?
Okay, okay. Now we will solve it. We will solve it. No problem. So multiply this 9 with this 2, and this is 3. Okay. This will be 36. And 10, this is 10 to the power 9. And this is 10 to the power 6. This is 10 to the power 6. This will become 10 to the power minus 9. And this will be 10 to the power 9. Means 10 to the power 0 means 1.
Yes, sir.
1 is nothing. 1 is something, but here is nothing. In multiply, there is no effect of 1. And what is here? This will be 3 3s are 9 into 10 to the power minus 6. Now this will be what? Minus 6.
Yes.
So is it fine now? Huh. This will be 4. I think this answer is correct.
Yes, sir. I forgot the square in the denominator.
So like this, you can calculate the powers. First, you should, what should you do now in these types of calculation? First, try to calculate the powers. This here is 9 minus 3 and like this. And oh, one, sorry. Sorry. This will be 72 now. No, sorry. This will be not 72. 54.
54, right?
No problem. That is the calculation part. Is 54. So this will be 6. So answer will be 6 into 10 to the power 6 Newton. So this is
Yes.
just for your just for the calculation, and there is next question, and hope you have noted down.
Yes, sir.
Okay. Now there is next question, and this is a very good question. Like two charges, Q1 and Q2. You should remember this formula, na? This formula is very important for the numerical. Q1 and Q2. When placed at a separation R, repel each other with force F. With force F. Calculate force between them when magnitude of both charges is double. and distance and separation, you can say, is half. You can say becomes half or is half. That's not a problem. You should understand the question. And what we have to do now? We have to find the value of force. And in this question, firstly, the charges are placed in air. Na? This is one charge, this is another charge. These are separated by distance r. These two charges. This is Q1, this is Q2. So now we are given with force. Force is given now this F when in air.
Yes, sir.
In air. So you should consider here air placed at A. You should add in air. If no medium is given, na, you should consider air as a medium. Okay, air is as a medium. If nothing is given, so what is the value of F? F will be simply K Q1 Q2 by R square. This is equation 1.
Yes, sir.
And again I am these charges are placed in air. So now what happened? The magnitude of these two charges becomes, after that what we have done, we have increased the magnitude of both the charges to double. Means this charge will become 2q1 and this become 2q2, and this distance will be half r by 2. Fine, na? Hello, am I audible?
Yes, sir.
So this distance become half in the question. Force F, calculate the force Pvt Ltd when magnitude of charges is double and separation is half. So now what is the value of F? I am supposing this F dash. Now the force will change now. The
Yes, sir.
charges change and distance change, as force depends on the charges and distance. So I am supposing this is not F. This can be something you can take F1 or F dash. I am taking it F dash. So now what is the formula? K medium is same. Q1 means 2q1.
2q1.
2q2 divided by r upon 2 square, and F dash can be written as, this will become 4, 2 to the 4, multiply 2 with 2, 4 K Q1 and Q2, and this will be R squared divided by 4, and this 4 will multiply with this, means 16 K Q1 Q2 divided by R square. And now let's see. We have this, na?
Yes, sir.
What is this? F means F dash will be 16 times of F. So simple.
Yes, sir.
Is it fine now?
Yes, sir.
No problem. Completed?
Yes, sir, completed.
Good. Now there will be a term when you place the charges in some medium. There is term we will study. Dielectric constant and relative permittivity. Dielectric constant and relative permittivity. Earlier, what we have done, the charges are in when the charges are in air. This is Q1 and this is Q2 and this is the separation. So F air, I am representing F force in air like F naught. Okay. So this will be 1 upon 4 pi epsilon naught. Okay. And Q1, Q2 divided by R square. Now what I have done, I have placed this whole system in some medium, other than air or vacuum. So now in between the charges, there is no air, no vacuum. So I have told you earlier, like if there is some medium, then we will use epsilon naught, this epsilon naught only. So here will be epsilon naught. Okay. But in the questions, we have the examiner, or in a question of book, we will not get this value. We will have the value of K, dielectric constant. And there is a relation epsilon upon epsilon naught equal to K. Now from here, can I calculate epsilon now?
Yes, sir.
So problem is solved. And this K will be given, and this will be given, and this we got from this. So this is not F0. Force in some medium. Okay. Now suppose this is equation 1 and this is the equation 2, and now I am dividing equation 1 with 2. So when we divide this equation, This will be F naught divided by Fm.
Yes, sir.
I am dividing equation 1 with 2. So in the LHS, F naught by Fm. And these terms will be cancelled out. Q1 Q2 by R square, Q1 Q2 by R square. And 1 upon 4
Yes, sir.
pi will be cancelled out now. Okay. And what will have? We have this term. Here is F naught, means in the denominator will be epsilon naught. Here will be epsilon naught and here will be epsilon. And we know that epsilon by epsilon naught equal to K. So from here we can, this is the force in air, this is the force in some medium, and this is equal to K. K is dielectric constant. And from here now I can calculate the value of Fm by F naught by K. And this K in general greater than or equal to 1. If this K is greater than or equal to 1, what does it mean? It means F naught is always greater than Fm. Is it okay now? If this K is equal to 1, at that time these both the values will be same, but generally K is greater than 1. So this value is greater than 1, means this whole value will be less than this now.
Yes, sir.
Hope you have understood that.
Yes, sir.
So, and this F naught is, this is force in some medium. And this is F naught force in air or vacuum. And what is this? Is dielectric constant. And we have some values of K, like if air is in between the charges, then K is equal to 1. Actually, please remember, this is not this K. This is another K. This is another K, na? This is K constant. This is not dielectric constant. Okay. So, you may got confused. So, instead of K, you can also write K as epsilon at R. Okay. This is also known as dielectric constant.
Okay, sir.
Please, those two K's are there now. Both the K's are different. Here K is dielectric constant. And there in Coulomb's law, the K is constant of that medium. And K is 1 for air. And K is infinite for conducting medium. And K is
Okay, sir.
equal, what?
Nothing, sir. Okay, sir.
Water. And so from here, if I want to calculate the force between the charges, placed in conductor. So placed in conductor means F conductor equal to F in air divided by epsilon naught R, or you can say K. So we have used here formula, this formula Fm is equal to F naught by K. We want to find the force in some medium. Medium is conducting medium, like conductor, we know conductors, and also air. And what is the value of K for conducting medium or conductor? Infinite. So 1 by infinite is equal to 0. So force in between the charges when placed in conducting medium is 0. Okay. Suppose these are two charges, and this one hand is one charge and this one hand is one charge. In between these charges, there is a conductor, conducting medium. So there will be no force in between these two charges. Okay.
Okay, sir.
Okay, fine. We have one more question, and after that, have you completed this?
Yes, sir. Finished.
Okay. So have you understood this now? Why I am writing this? Because you should remember this formula also. Force in air, force in some medium. This will be K, and K, you can also say K as dielectric constant is also represented by ER, also known as relative permittivity. Two charges, Q1 and Q2, when placed at separation R in air, repel each other with a force F. At what separation they must be placed in a medium of dielectric constant free. So what we have here, two charges, we have two charges, they are placed in air, like there are two charges, Q1 and Q2. This is the last portion of this class. Please have patience. These are two charges and placed in air with a separation R. So what is the force? I can write this as 1 upon 4 pi epsilon naught Q1 Q2 divided by R square. This is equation 1. This is the last question, okay?
Yes, sir.
And if you don't want to write this question, then you can leave. And do you want to leave the meeting, or should I complete this question?
No, sir, you can complete the question.
Okay. Now, these charges are placed in. Okay. That's all for today. I should end the class now, and that's all for today. Okay.
Okay, sir.
Okay. So we have discussed these things. So please try to understand these things. Okay, that's fine. Now you can leave. Thank you.
Okay, sir. Thank you, sir. Bye, sir.